first question. First of all, what is this? Beta, but what is that? It's an angle. So anytime you see a Greek symbol like alpha, beta, theta, and WebAssign uses a lowercase t, that stands for an angle. So this says the sine of some angle we're going to call beta has a ratio of -1/11. Okay, and it's in quadrant 3. So what I noticed yesterday on your quiz is that you kind of lost control when the triangle was just in a plane and not on a quadrant like we're going to do here. And so this should help you figure out how to do those triangles. Okay. When we do a triangle on the unit circle, we're always going to start at the origin. So put your pencil at the origin. Okay. I need for you to imagine like a butterfly. And you're not going to use the y-axis as a side, which is what a lot of people try to do. But what I want you to do is come down here and then go up and make your triangle like that. So this one on the fourth quadrant would just be reflected over the y-axis. And then they would look reflected over the x-axis in quadrants 1 and 2. So put your right angle in. Now where's beta? At the origin. So we're going to put beta right here. This gives us perspective. Now I know where I can get my ratios. So it says the sine of beta is -1/11. Okay, so how do I label my triangle? What's the ratio for sine? y/r. So when we're on the unit circle, let's try to use the x's, y's, and r's so that we can get used to that and kind of move away from SOHCAHTOA. So my y would be what? -1. In the third quadrant, y is negative. Then what's r? 11. Okay, I'm going to say this probably a lot today. Your y value and your x value correspond to the quadrant that you're in. The r value is always positive. No matter what quadrant that you're in, your r value, your radius, is always positive. Why? It's a distance from the origin to a point on the circle. So then, explain this to me. If any of these really are distances, why is that negative? Why is the 1 negative here? If that's a distance, if it's just a distance on the vertical, why is it negative? Well,
because technically, since that's a ratio of it could be like -1/11 could be multiples of that. But since we're using specifically 11 as the radius, then we would have to use specifically -1.
So we're in the third quadrant. But my question is this. If I am only talking about side lengths as distances, what is it about the location that makes that negative? There's a different way for me to think about that negative. Could I not think about it as like a transformation? What does the negative do for you? It flips it over the x-axis. So it's really just a distance of 1 that's been reflected or flipped over the x-axis. That's why it's negative. The radius, however, that doesn't apply to the radius. The radius is a distance from the center of the circle to a point on the circle, and it is always positive. Okay?
You and I think different because I got that.
Well, that's fine. It's okay if you think about it a different way. All right, now, what are the 6 trig functions? Well, I can't do the other trig functions until I know what? I don't have x. So we're going to use x squared plus y squared equals r squared. Okay, so what do we know?
Y and R.
So x squared plus -1 squared equals 11 squared. X squared equals 120. And so x would be, are you sure? Negative square root of 120. I don't need to simplify the radical, but I do need to apply a negative. Why? It's in the third quadrant. Negative square root of 120. You have to apply the signs for the quadrant that you're in order to get these correct. All right, so then we pull out the trig functions. And we say the sine of beta, we already knew they gave it to us. It was negative 1 over 11. The cosine of beta,
Negative 120 over 11, or negative square root.
negative square root of 120 over 11. And the tangent of beta,
Is negative 1 over negative square root of 120.
so it's y over x, and so a negative over a negative would be, so it would be 1 over the square root of 120. Now, you certainly could rationalize, and you certainly could reduce that radical, but you don't have to. All right, now let's go do the what's. What are the other three called?
Cosecant.
What are they, though?
Reciprocal.
Reciprocals. They're not inverses, they're reciprocals. We will do inverses later, but they're not inverses. So this would be the reciprocal of sine is cosecant. And how do I get that?
11 over negative.
Yeah, so it's negative 11 over 1, or however you want to do it, but the sign was negative before, so the sign is still negative here. All right, what about secant?
11 over negative 11 over 1 square root.
Okay, so if the sign for cosine was negative, then the sign for secant is negative. And then we have cotangent of beta.
It's
It's just the square root of 120. Yes, ma'am.
When we're like, if we're doing a sine test, do we have to put like sine of beta, or do we just put like sine?
Okay, that is an excellent question. You can't just put sine. Because if you just put sine, well, actually it would be sin at that point, right? Because it's just sin. Without an angle measurement, then it's just a sin. So you have to put the symbol. And you can use alpha, you can use beta, you can use theta, you can use x. But you have to put the actual angle notation. Because what you're saying is that there is an angle out there somewhere that has a sine, cosine, tangent ratio of whatever we put. So yes, that's a great question.
But if it gives us like a certain symbol, does that mean that we have to use that same?
For me, no. I don't care. For WebAssign, it does care. So if WebAssign gives you a theta, then you have to continue with the theta all the way through if there's a reason for you to put that in. If it gives you an x, continue using an x. Or a t, continue using a t. Personally, for me, I don't care. Okay? All right, any other questions on this one? All right, next question. Find all angles that satisfy the cosine of beta is root 2 over 2. And I've actually got 3 different problems on here that I'm going to show you. This is the one on WebAssign that says separate your answers with a comma and write your answer in terms of k. Does this ring a bell from WebAssign? If you've looked at WebAssign, then you've seen it, right? Okay. So first we have to define k. What is k? K is a variable in trig that stands for the number of rotations. So if K is 1, that means you make 1 rotation. If K is 2, you make 2 rotations. So that's all it is. From this point forward, anytime you see, and it's got to be a lowercase k. So when you put your answers on WebAssign, don't do a capital K. You don't need a Greek symbol K. It's just a K on the keyboard. All right? Now, I'm going to sketch this out. What angle that we call beta has a cosine value of root 2 over 2? So if I sketch this in, you agree that that's 45 degrees. Okay, now, WebAssign wants it in radian measure. So I can't use 45 degrees, I have to use pi over 4. So this distance is pi over 4. Now, is there any other location on the circle that would also have a cosine ratio of root 2 over 2? 315. It does. It says that it's positive, right? So 315 is my other one. I'm going to do that one in blue. So this one would be all the way around here to about right here. And what are we going to call this? 7 pi over 4. Okay, now here's where the pi k and the 2 pi k come in. How much rotation is pi k, if k is 1? Half a rotation. It's around halfway, like a semicircle. What kind of a rotation is 2 pi k if k is 1? It's a full rotation. Okay. What they're trying to get you to understand is that if you make multiple rotations, either in terms of pi or in terms of 2 pi, you should get back to where you started. So, if I start with pi over 4, start with pi k. If I add pi k to this, where am I now? I'm at 225. Is that where I want to be? So instead of adding pi k, I need to add 2 pi k. Comma. Where's my next one? 7 pi over 4. If I just add 180, where does that put me? At 135. Does that have a positive cosine of root 2 over 2? So I have to make a full rotation. It's okay if you don't quite have it yet. I've got 2 more examples to show you. The first thing I want you to understand is what k is. K just means the number of rotations. The second thing I want you to understand is you can think in terms of degree, but when you put your answer in, you have to do it in radian measure. You can't say 45 degrees plus 2 pi k. You would have to say pi over 4 plus 2 pi k. All right? Let's try another example. What about all angles whose sine is 1/2? So what should I do first? Sketch it out. Okay, so I'm going to use my hand, and I'm going to make my hand show a sine of 1/2. Where am I? 30 degrees? Okay. So if I'm at 30 degrees, remember we have to think in terms of radian. So what's the radian measure for 30 degrees? Pi over 6. So I'm going to come out here, and I'm going to label this as pi over 6. All right. Where else would I find a sine ratio of positive 1/2? At 150. So if I come around here, what is that radian measure? 5 pi over 6. Okay. So now we start here with pi over 6. If I make a pi rotation, where am I? I started at pi over 6. I make a pi rotation. I'm at 210. That's not going to work, is it? Sine's negative down there. So what kind of a rotation do I need to make? 2 pi plus 2 pi k. All right, now go to 5 pi over 6. If I make a 180 rotation, where am I? I'm at the 4th quadrant. I'm at 330. That's not far enough. I need to go all the way back around. Plus 2 pi k. Yes, ma'am. Okay, what does 2 pi stand for in the unit circle? A full rotation. What does k mean? The number of rotations. So if I say 2 pi k, where k is 1, that means 1 rotation. If I say 2 pi k, where k is 2, that means 2 rotations. Let's be right back at the same spot. What they're trying to tell you is that you can go around the circle multiple times and still end up at an angle that has a sine ratio of 1/2. That's why you're adding it to the angle that you start with. You're either going to be adding a full rotation, 2 pi k, or half a rotation, pi k. I'm so glad you asked that. Example number 3. All right, so let's do this one. Where do I start? Sketching it out, right? Start out with this. Okay, where does the tangent equal 1? 45 degrees. So I'm going to come up here. I'm going to show, I'm going to have to do it in radian, pi over 4. Is there anywhere else at 225? So if I come around here, what's that radian measure? Pi over 4, 3 pi over 4, 5 pi over 4. Okay, now I start here, pi over 4. Start out with pi k. Where am I? I'm where I need to be. So it's okay on this one to say pi k. If I just do plus 2 pi k, what do I leave out? I leave out the 225. If I only make a complete rotation, then I leave out this guy. And this guy has, this angle has a tangent ratio of positive 1, just like they said. Well, no, it says if necessary, separated by commas. But see, it's not necessary here. Now, I could split it up. So let's say that I did this. Okay, let's say that I said pi over 4 plus 2 pi k. That gets me all the way back around. Then I've got to say 5 pi over 4 plus 2 pi k. But isn't this the same thing? So it's probably going to mark that wrong because it's looking for this. It's wanting you to understand that on this particular example with tangent, you only had to make a half a rotation. Tyler. One time. I want you to go 180.
Okay.
If k is 2, what have I done? I've got, no, if k is 2, that means I went, what is pi times 2? 2 pi, which puts me back here. If it's 3, it puts me here. Even rotations would be all the way around. Odd rotations would be 180 degrees. Yes, Jimmy.
When you say 2 pi k and you're adding it to pi over 4, and you go 4 rotations, it goes back to pi over 4?
Actually, no. It would be pi over 4 plus 2 pi. So pi over 4 plus 8 pi over 4 is really 9 pi over 4. So it puts you in the same spot. So what does that mean those angles are? Coterminal. That's how you find coterminal angles.
I just don't get, like,
Well, the point is another way to reinforce coterminal angles. But the other thing that we're trying to reinforce with these questions is where can you find similar angles with the same ratios? Here and here. In first quadrant and third quadrant, tangent is positive. So if you start here and you go 180, you're going to get a value that's exactly the same. It's just coterminal angles. It's another way to think of coterminal angles. All right. Next is this. This is a concept that is really important, especially as we move towards graphing on Monday. Can anybody read that to me, like in English? What does that really say? Cosine of
Beta.
some angle we're going to call beta. Because we don't know what it is. We don't know what the angle is. But I'm asking you, cosine of what angle is going to give me a ratio of 4? Is there a way for me to make that a ratio? It's not a ratio now, but what can I do to it? 4 over 1. Okay, so I want to do it like this. Now, to explain this question, I'm going to sketch this. And I want you to give me the ordered pairs for the quadrantals. So what's that ordered pair at 0 or 360? 1, 0. Okay, at 90, 0 and 1. At 180, -1, 0. And at 270, 0 and -1. And do you remember the first day we did this? We said there's a difference between the unit circle and a circle. And we said if it was on the unit circle, it had to have what? A radius of 1. So since we made a ratio out of this, by putting it over 1, The question implies that we are on the unit circle. So now, here's the question. What angle on the unit circle has a cosine ratio such that the x value is 4 and the r value is 1?
None.
None of them. Why?
Because one's the hypotenuse, so automatically it couldn't be over one.
That's right, because the triangle won't even close at that point, will it? If the hypotenuse is only 1, and it's supposed to be the what side of the triangle? The longest side, how could x possibly be 4? Right? So the answer to this question, all caps on WebAssign, is no solutions. You don't have to? Okay. All right, now when we graph on Monday, and I don't know how much graphing you guys did last year, but when we graph on Monday, we're using yarn and big pieces of paper and things like that, but you'll see that the peak for sine, the peak is positive 1. And the valley will occur at negative 1 on the unit circle. Now, are there ever going to be sine or cosine or tangent or sine or cosine graphs that are higher or lower than that? Absolutely. How does that happen? A transformation. A transformation. A stretch will be applied, which we won't call a stretch, we'll call it an amplitude. That's
So just to be specific,
Uh-huh.
so sine and cosine always relate inversely to each other.
They do, with a shift of pi over 2, which again you'll get when we graph. You're right. All right, let's see if there's another one. Nope, it's on the next page. All right, so let's do this is 2 different questions, so I wanted to make sure that I separated the 2 so that you would know what they were asking. The sine of beta is negative 1.02. So in English that says, what angle on the unit circle has a sine ratio that is negative 1.02? None of them. And that's because if the hypotenuse is 1, and that's supposed to be the longest side, there's no way that the y could be bigger than that. The triangle won't be a triangle anymore. It won't close. See why all that triangle stuff in your geometry class is important, about which triangles are possible. Did y'all ever do an activity like that where they gave you the lengths of 3 sides and they said which ones are possible? Swiss cheese. Like I said, you guys are Swiss cheese. Okay, now this one's different, and I need to explain this one, and so I want you to take a calculator out because I'm going to show you what this actually means. So on some of the questions on WebAssign, it says something about the mode. Be sure to change the mode or something like that on your calculator. And what that means is this. You need to be going from degree to radian or radian to degree. So how are you going to know what mode to be in? That's it. Shelby's right. If it has a degree symbol, put your calculator in degree. If it does not have a degree symbol, then you can assume that it's in terms of radians. But now here's my question. This one has no degree symbol. So it is in radians. Where's the pi? In the number. That's exactly correct. The pi has been multiplied and it's in the number. And I'm going to show you something in just a minute after we do this answer. I'll show you what I'm talking about in terms of pi, not in terms of pi, and hopefully this will make sense. So how do you do this question on your calculator? Make sure you're in radian mode. So hit the mode key, put it in radian, and then literally sine negative 1.02. And tell me what you get. Negative 0.8521. Okay. All right, so now let's do one that you know. Let's try the sine of 30 degrees. You know what that is, don't you? Here's 30. What's the sine? 1/2. Okay. That's in degree. Okay. Okay, let's do radian measure in terms of pi. What's 30 in radian measure? Isn't the sign still 1/2?
So wait,
In radian, in terms of pi.
so you would literally divide pi by 6.
Literally. So now, take your calculator and hit the pi button. Don't put in 3.14. Hit the pi button because that's your irrational key. Divided by 6 and give me that value. I want the whole thing. Okay, so 0.5. Hang on. Shelby, give it to me all at one time.
2, 3, 5, 9, 8, 7, 7, 5, 6.
Now do sign and then go second answer in your calculator so you capture that whole thing. 1/2. Yeah. That's still radian, but it's not in terms of pi. Are you following that? Okay. Degree is just 30 degrees. The sine of 30 degrees is 1/2. In radian measure, in terms of pi, we leave the pi in the angle measure, so pi over 6. If you put your calculator in radian mode, to do this one, put your calculator in radian mode and do pi over 6, sine of pi over 6 is 1/2. Now, take your calculator and do the math. Pi divided by 6 gets you this number. The sine of that number is still 1/2. It's 3 different ways of expressing the same angle. One is in degree, one is in radian in terms of pi, and the other one is just radian. You follow? Sure.
I was thinking like that.
The pi has been multiplied or divided. Okay. Next question. Tangent of 102.5. What's the first thing you need to do? Change your calculator mode to degree mode. And you're going to get how did I know it was negative before you even told me? Yes, you do. 102.5 is where? Second quadrant. And tangent in the second quadrant is negative. Figure out where you are on the unit circle. Now, is that an angle that comes from a special right triangle? No, but I can still find it. I just have to use my calculator. So there are several on your web assignment that ask you to do this. Be careful because it'll tell you how far it wants you to round. So round properly. Okay, now this is a word problem. I know how much you love word problems, so I thought I would help you out with this one. Okay, I'll read it to you. Suppose that theta is an acute angle residing in a right triangle. And by the way, everything we're doing right now is called right triangle trig. When we get to non-right triangle trig, it's law of cosines. All right. If the length of the side adjacent to theta is A, and the length of the side opposite theta is B, and the length of the hypotenuse is C, and then it gives you some ratios. That's just a theorem about ratios for SOHCAHTOA. That's all that is. They basically just wrote out in words SOHCAHTOA and how you get this ratio. That's all that is. Okay. If theta is 79.12 degrees and the hypotenuse is 5180, how long is the side adjacent? And it does say round to 2 decimal places. So the first thing we need to do is sketch the triangle. And we know it's right triangle trig, so we're going to make it a right triangle.
No, I'm not gonna say that. Well, I gotta get some question. Wait, can I say something?
Yeah, say something.
Okay. Wouldn't you technically Wouldn't you technically take that angle there, then you would cosine, but that would give you the ratio of it. So then you would multiply that answer by 5,000.
You do. We'll get to that. That's exactly what we're going to do right now. He jumped ahead to the actual solution. Listen. All right. We have to set the triangle up according to the sides the way that they gave it. And so it says that theta is an acute angle. And honestly, it doesn't matter if you decide to put it at the top or the bottom. I'm going to put it at the top just because. 79.12 degrees. Now, everything I do, though, is now from that perspective. So it says that the side opposite, or the side adjacent is A. So that's A. And the side opposite is B. And then the hypotenuse is C. And they gave that, it's 5180. And then it says, how long is the side adjacent? So which of those sides am I trying to find? This is what I don't know right here, the question mark. Okay, so now what I have to do is think about which trig ratio I have. And that's what he was saying. Can't you just do cosine? Yes. If I want this, from this perspective, it becomes the cosine of 79.12 degrees is equal to the ratio of adjacent over 5180, or the hypotenuse. Okay, you need to know something about your calculator, though, before you get started. First, you got to be in degree mode. Second is this. When you hit the cosine key and you open up one left-hand parenthesis, right? Put in your 79.12 and close it. Then multiply it by 5180. If you don't, then you're really finding the cosine of an extraordinarily large angle. Or you can do 5180 times the cosine of 7912. Multiplication is commutative. That part doesn't matter. But you need to be careful with your syntax. So, A then is 0.7. It says 2 decimal places. Okay, now, I have a question. Could I have first found B and then done something else to find A? What is that thing that I could have done? Okay. Now, I'm talking 2 calculations versus 1. So obviously cosine is the smartest way to go. But I do want to point out that if you had found the sine of this first and gotten B, then you could have used Pythagorean theorem to find the missing side. And that's fine. But here's the key to doing that. If you do it that way, you've got to make sure that you don't round until when? The very, very last answer. So you'll have to maintain all those decimal places in your calculator till the very end, and then if you round every single calculation that you do, by the time you're finished, your answer is really far off from what it's supposed to be.
Well, that's kind of fruitless though, because if you were to do it for B and then find A through the Pythagorean theorem, you'd be doing the same thing for A just with the Pythagorean.
I know, but the point is, it's not wrong to do it that way.
I mean,
It's multi-step, but it's not wrong. It's not a wrong ratio to set up opposite of hypotenuse.
That seems like going around the problem instead of going right through.
Okay, I get that, Mom. I understand that you're going around the problem to get to the answer, but you have to understand that not everybody thinks directly. Some people will look at that and they'll go, oh, I know how to do sine. I'll get this side. Can I do it? Absolutely, you can do it that way. I'm not saying it's the fastest route, but not everybody takes the fastest route. So they have to know what is okay to do and what's not okay to do. All right, next question. Just so you know, you're being recorded. So keep it up. Because everybody knows this is coming from 4th period. Okay? All right. For the point, let theta be the angle in standard position whose terminal side contains this point. So this time they didn't tell you what quadrant it's in because it's obvious based on the ordered pair. So if I sketch out 3, -6, 1, 2, 3, 1, 2, 3, 4, 5, 6. Here's my point. Standard position means that the angle comes from the origin. We're going to draw it the same way that we did before. We're going to come down here, and we're going to go up here. Don't use the y-axis as your y value, like a butterfly, okay? So now I'm going to label this with a 3, and that with a -6. All right, what do I need to find now? Hypotenuse. So 3 squared plus -6 squared equals r squared. 9 plus 36 equals 45, right? And so r is square root of 45. So we'll put that in here. Is it negative? Why not? Can have a negative radius. All right, all it asked me for was cosine and sine. So the cosine of theta is
-6 over the square root.
3 over the square root of 45. Ratio of x to r. And the sine is -6 over the square root of 45. Okay, so now I have a question. Y in this problem is cosine not just 3 and sine not just -6. That's why we did it in the unit circle. It's not the unit circle, it is a unit circle, and I know that for certain because the r value is not 1, it's actually square root of 45. I'm still doing ratios in the unit circle, it's just the denominator, the ratio for the radius always is 1. It's always whatever x is over 1. But I'm still using the same ratios. I don't want you to get confused and think that there's a time when I'm just looking at the x coordinate and I'm just looking at the y. I'm still putting it as a ratio, it's just the radius is 1. Alright? Last question. A tree standing vertically on level ground casts a 125-foot long shadow. The angle of elevation from the end of the shadow to the top of the tree is 20.4 degrees. Find the height of the tree to the nearest foot. So I should draw a triangle. Well, actually, I'm going to draw a tree-ish.
So I wasn't.
You weren't wrong. Look, here's my tree. There's my tree. Okay, now, the tree standing vertically on level ground casts a 125-foot long shadow. It's at the bottom. That's it. And then it says the angle of elevation from the end of the shadow. So this bottom right corner gets 20.4 degrees. Okay? Now I want the height of the tree. So this is what I don't know. What ratio should I use? Tangent. So tangent of 20.4 degrees is equal to we can call it x over 125. Remember, you can either put the 125 in first times the tangent of 20.4, or close out your parentheses around the 20.4 times the 125. And it says round to the nearest foot. So give me the answer first, and then we'll talk about how to round it. It's 46 point something, right? All right, so feet. And then it says round to the nearest foot. So 46. If this had been a 5, then I could round up. But I can't round that to a 5 and then round up. Got it? Okay, so this may be somebody's question. A lot of them, what I did is I copied the question, literally just did a copy paste of the question, and some of them I copied the question and then I changed the measurements just a little bit so you'd have an example. But this completes every single, look, nothing there. Every single letter sign question except for the graphing you should have completed before we start Monday. So you have 30 minutes, more than that, 40 minutes almost, to work on WebAssign and get it finished. And because you can go to the media center